All right, hey guys, I'm gonna go over now the chain rule, and I'm gonna go through like pretty good amount of examples, like 10 examples where they're all unique, so you can see like the different types of ways the chain rule can be applied. So let's get going. The chain rule. This is gonna be dealing when you got a composite function. So you won't be able to see me for a second, but I'm here. Hey. You want to take the derivative of a composite function. Let's say you have f of g of x. Right? You want to take the derivative of this. So the inside function is the g of x. Let's put that in red. What this says is that you take the derivative of the outside function, which is the f of x, or the f of g of x. So you do f prime, and you leave the g of x as is. And then you multiply this by the derivative of the inside, or the derivative of g of x, so g prime of x. Yeah? So that's the rule. But let's apply it because it's confusing when you first see this. I know it was for me. So let's look at some examples. For beginning with, where should I write this? Let's write this over here. We got y equals 3x squared plus 1 squared. Yeah? So then what you got is that the inside function is this 3x squared plus 1, okay? So you have an outside function that's just the squared one, this power, and the inside is this red. So if I want to find y prime, I take the derivative of the outside. So the power, the derivative of the power, so the power rule, we go 2 times, and we leave the inside as is for the first part. So 3x squared plus 1. And then you multiply it by the derivative of the inside. So you multiply that by the derivative of 3x squared plus 1. And that's going to be 6x. And we can simplify this, and this will give us 12x times 3x squared plus 1. Or let me finish it. Let me see it. Let me go all the way here. 36x squared plus 12x. All right. Nice. Whoa. Let me zoom out a little bit just to make sure we're all good here. There we go. All right. Let's do another one. Forgot to bring my children. They want to come. Hey guys. All right. Example 2. Trig. Let's go over here. Yeah. We have y equals the cosine of x squared plus 1. And so, inside function is the x squared plus 1. The outside function is a cosine function. So y prime will be, take the derivative of the outside. So take the derivative of the cosine function, which will be the negative sign of, keep that the same. And then you multiply it by the derivative of the inside. Multiply it by the derivative of x squared plus 1, which will just be 2x. That's really your answer. You can write this maybe more cleanly like this, negative 2x times the sine of x squared plus 1. Simple. Nice. Whoa. Let's look at another one. Example 3. we have y equals sine of x squared plus e to the x. Oh, here we go. The inside is this. X squared plus e to the x. The outside is the sine function. So y prime will be equal to the derivative of the sine function, which is the cosine function. The black pen is dying. Come on, let's get through this. Come on, okay. Now we can throw it away. I missed. Anyways, now we take the derivative of the x squared plus e to the x, which will give us 2x plus e to the x. And let's just leave it like that so we don't waste more time, because that's our answer. But understand this is not like the cosine of this whole thing. These are different. So maybe some brackets will be a little easier to distinguish that, but that's not an issue. Yeah, it's not a big deal. All right, number 4. Okay, so let's look at this. The natural exponential. We got y equals e to the cosine of x. So you have like the cosine function as a power. Let's just make this one well, let's make the e the red. Let's make the e in red. So we take the derivative, and let's actually put this in parentheses. See, so you got the exponential e function, which is the red, and the inside function is the cosine. So we would just have that y prime, the derivative of e to the x, or e to the cosine of x, would just be e to the cosine of x. And this whole thing will be multiplied by the derivative of cosine of x, which is negative sine of x. Gotta get down low. And let's simplify this to make it look a little cleaner. Let's put this in the front. This will be the negative sine of x multiplied by e to the cosine of x. And that's your answer. Let's keep it going. Yeah, let's keep it going. Number 5. Let's erase it all. Let's start fresh. All right. I want to go over here. Example 5. We got y equals the tangent of 5 minus sine of 2x. Okay. So the derivative, the inside function will be this. Oh, should we just wrote it in red? Oh, we got triple. This is a bonus one. Actually, let me do this. Let me just rewrite it nice. So we have the outside function, the tangent of this. This is the tangent function, the one in black. Then we have another one, which is the 5 minus the sine of whatever's in there, and the innermost is 2x. Whoa. Actually, well, I mean, yes and no, because I don't want to confuse it, but so technically you could say you have 3 functions going on here. So outside function. I'm probably gonna need more space. Let me go over here. So y prime will be the derivative of the tangent function, which is the secant squared function. And we keep all that the same. 5 minus the sine of 2x yeah? Okay, then we go one in, one deep, one, the derivative of the red function. And let's actually put this like in brackets so we don't. So we make sure we multiply correctly. Then we go, the derivative of 5 minus the sine of 2x is going to be minus cosine of 2x. So we don't mess with, let's not mess with the blue, not yet, so we don't confuse ourselves. Now we do. Now we multiply by the derivative of 2x, but everything, you know? That's why I'm using these brackets, which is just 2. Yeah, see? And then it's this thing. And it probably will be more cleanly understood if you write it as y prime is negative 2 cosine of 2x multiplied by the secant squared of 5. Where's my eraser? Five minus the sine of 2x. And oh, I know what's gonna happen. They're gonna probably put this as because you could put secant of x as 1 over the cosine of x and cancel. Well, actually no, because well, this is a different one. Okay, so we're good. Don't gotta worry about any like tedious work. That's our answer. Hooray! All right. Let's look at a couple more where they're going to be with powers. This is just showing you different. These are good examples, of course, but let's look at ones where we're focusing on these powers. You're going to get powers like crazy. So over here, we have. Let's go over example 6a. So we got y equals 5x cubed minus x to the 4th, all to the 7th power. Yeah? I'm actually going to write all the examples right now, all the remaining 4, so that I don't have to worry about writing them. So b will be y equals 1 over 3x minus 2. C will be y equals the sine of x, but this is all to the 5th power, so the sine, the 5 will be over there. And then D, we have y equals e to the square root of 3x plus 1. All right. So again, maybe try these on your own first to see if you can do them. So, pause the video and then unpause it when you're ready to check. Because here I go. All right. So here we have this power, this giant power, 7. So we start off by taking the derivative of a polynomial to the 7th power using the power rule. So we're going to get y prime equals 7 times, leave this the same, 5x cubed minus x to the 4th, all to the 6th power. And then we multiply by the derivative of this part, the 5x cubed minus x to the 4th, which will be 15x squared minus 4x cubed. And yeah, I mean, I would just leave it like this because the multiplying out is just the algebra part, which is not what we're focused on right now. Yeah. All right, so let's go and look at B. So here you will notice that it appears as a fraction at first, and then it's like you may have to use the horrible quotient rule. And we don't want to do that. We don't want to do that because, yeah, it's just, I don't like it. So let's change this into y equals 3x minus 2 to the negative 1 power. See? And from here, you can just use the power rule. It's much more fun. So using the power, the outside one is the red. So you take the derivative of a term raised to the negative 1. So that'll be negative 1 times 3x minus 2 to the negative 2. And then you multiply this by the derivative of 3x minus 2, which is 3. And rewriting this, you'll get that y prime. Bringing this to the bottom, you'll get negative 3 over 3x minus 2 squared. Yeah. Okay, a couple more. For C, we have the sine, the fifth power of this. So I would actually rewrite this as, let's remember that this is just having the sine of x being all raised to the fifth power. I should put that in red. They just use this. This is just a special notation, but it means the same. Hey guys. So we start off, take the power rule. So we'll go, where should I go? Over here. So y prime is the derivative of the fifth power function, or the power function using the power rule will be 5 times the sine of x to the fourth. Then you multiply by the derivative of the sine of x, which will be the cosine of x. That's pretty much your answer. And you can write this as 5 cosine of x times the sine of x all to the fourth power. So you may see it like, where should I put this? Let's just go over here. So you'll probably see this as 5 cosine of x times the sine, and the fourth power will be right there. That's probably how you see a solution in a textbook. So make sure you understand. Same thing. All right, one more. We have this. Okay, so let's do it down here. So we have the red function. Then you have the black. And inside here you have 3x plus 1. You have 3 functions. The red, the black, the blue. So let's work this through. Well, I kind of want to do it up there so I don't have to bend down over here. So we're going to travel over here. Let's erase this part. So we have some room to work. Okay. So y prime will be equal to the derivative of the exponential, which stays the same. Whoa. So that would just be e to the square root of 3x plus 1. Now this entire expression will be multiplied by the derivative of the square root function. So remember, the square root is just like this whole thing being raised to the 1/2. So like, if I could, let me write this over here. So this is like 3x plus 1 to the 1/2. If I took the derivative of this, only focusing on the power, I would have 1/2 times this to the negative 1/2. So 1/2 times 3x plus 1 to the negative 1/2 power. And parentheses are your friend in these cases. Now all that is left to is multiplied by the derivative of the blue of the 3x plus 1, which is just 3. Yeah. Eat. Let me clean this all up. So this is going to be in the denominator, and remember it'll be the square root of 3x plus 1 in the denominator. So 3 on top. So we're going to have y prime equals 3 e to the square root of 3x plus 1 all over 2 times the square root of 3x plus 1. And there you go. Oops, whoa. Nice, cool. All right, so there are, that was 9. Close enough. 9 solid example problems for you to master the chain rule. So please hit me up with any feedback questions or anything that you notice maybe I can improve on. And of course, subscribe if you haven't yet. And hit the like button, tell your friends, tell your parents, tell people that you don't even like, and I'll see you guys in the next video. Bye, guys. Thanks for watching.